Shri Gurubhyo Namaha. The FA4 physics topic for 8th standard is some natural phenomena. There are so many natural phenomena which occur in nature. You have the lightning, the earthquake, the landslides, the avalanches, the volcanoes, tsunamis and so many other things. So in this lesson we are going to see in detail about these natural phenomena. Before we enter into these natural phenomena, we need to know some basic topics or basic contents. There are so many things that we see around us. You have the buildings, the trees, the vehicles, the living things, the animals, human beings, so many other things are available in nature. All these objects are made up of very tiny particles called as atoms. How does an atom look, or how do we see an atom? An atom cannot be seen with the naked eye. It can be seen only with the help of a microscope. When we see an electron or when we see an atom through a microscope, how does it look, or what is the structure of the atom? I have drawn two examples of how an atom looks. Okay, this is an atom. In the center of the atom you have the nucleus. The nucleus consists of the protons and the neutrons. The protons are said to be positively charged and the neutron does not have any charge, or it is also called as a neutrally charged particle. Revolving around this atom you have the electrons. The electrons are negatively charged particles. In this atom if you take, there are 12 protons and 12 electrons which are revolving around. So the 12 positively charged particles and the 12 negatively charged particles neutralize each other and the atom is said to be neutrally charged. If you take the second example, you find that there are 8 protons. And revolving around the atom you have, around the nucleus you have 8 electrons. So the 8 protons and the 8 electrons neutralize each other and this atom is also is said to be neutrally charged. Now say this is an example of a atom which is present in wool and this is an example of an atom which is present in plastic. I take a piece of wool and I take a piece of plastic and I am rubbing against each other. You will find that these two electrons which are in the outermost shell of wool will move on to this plastic. Now you find that there are not 12 protons, there are not 12 electrons, there are only 10 electrons. So now after rubbing the wool and the plastic, there are only 12 protons and 10 electrons in the wool. Whereas here you find there are 8 protons and you have 10 electrons. Okay. So now this atom has more protons than the number of electrons. So an atom which has more number of positively charged protons is said to be a positively charged atom. And the atom in which the number of electrons are more than the number of protons is said to be a negatively charged atom. Okay. Now in this when we take these two atoms, whenever I say a positively charged atom, it means I am referring to an atom which has a deficit of electrons or less number of electrons than the protons. When I say an atom is negatively charged, it means I am referring to an atom which has more number of electrons. Okay. Now such type of transfer of charges is found in the nature also. You have during a thunderstorm, the clouds and the clouds rub against each other, or the clouds and the winds also rub against each other. When these rub against each other, there is a transfer of electrons between the clouds and the clouds, or the clouds and the winds too. So a lot of charges gets accumulated in the atmosphere. In order to prove these accumulation of charges or transfer of charges, the scientist Benjamin Franklin, he did a very simple experiment. He tied a kite to a rope and it is a silk string. The other end of the silk string is tied to a metallic key. Now what he did was, when this kite is flying up during a thunderstorm, the high amount of charges which are getting accumulated in the atmosphere, it passes through the metal key, through the kite and the string. When he brought a small piece of metal closer to the metal key, a spark was produced. This shows that some amount of charge is being transferred to the metal key through the kite. From where it would have come? It would have come from the atmosphere only. Okay. So now I told you that transfer of charges are taking place. How is it taking place? How does a neutrally charged atom become a positively charged atom, or how does it become a negatively charged atom? Now initially in 6th standard you all have learnt about magnets. In magnets you all have learned that like poles repel each other and unlike poles attract each other. Okay. So now this is an example of a positively charged atom because there are 12 protons and 10 electrons. Whereas here you find there are 8 protons and 10 electrons. So this is an example of a negatively charged atom. Okay. So in a magnet, if I bring a north pole and a south pole closer to each other, they will attract each other. Similarly, if I bring this positively charged atom and this negatively charged atom closer to each other, they will attract each other. If I have two atoms, both are positively charged or both are negatively charged, if I bring both of them together, you will find that they will repel each other or they will move away from each other. How do I make these atoms positively charged, or how do I make these atoms negatively charged? That is what we are going to see. There are 3 different ways by which we can charge an atom. Okay. The first method by which we can charge an atom is by friction. In friction, already a friction is a familiar term to you. How do you cause friction? When we rub two objects one against each other, friction is being produced. So when I rub two objects one against each other, the same case which we learnt earlier, rubbing a piece of wool and a piece of plastic, you find that few electrons from one atom gets transferred to the other atom. So one atom becomes positively charged and the other atom becomes negatively charged. So when I am charging objects by friction, two objects when I am rubbing each other, if one atom is positively charged, then the other object becomes negatively charged. So unlike charges are being found in two different objects. The second method by which we can charge an object is by induction. I will give you an example about this induction. Take a piece of scale and you rub it against your hair should be dry. So when your hair is dry, it is easy for the charges to get transferred. That is the purpose of mentioning it as dry hair. Okay. Take a piece of plastic and rub it against your dry hair. So I have taken a plastic scale. The scale becomes negatively charged. Now I bring this negatively charged scale closer to a piece of paper. Okay. So this is a paper. We find that the negatively charged scale will induce positive charges on the paper and the negatively charged electrons will be pushed out of the paper. This happens only for a few seconds or fraction of second only it takes place, because when we rub only few amount of charges only will be transferred to the scale. Okay. So in charging by induction, when I bring the negatively charged scale closer, I needn't have to touch the object, I just bring the object closer to the piece of paper. You find that opposite charge is induced in the other object. This is only called as charging by induction. So in both friction and induction, opposite charges are being induced. Okay. But you find that in friction the object should be in direct contact with each other, but in induction you find that it is enough only if we bring the object closer to the other object. We needn't have to have a direct contact with the object. Okay. The last method by which we can charge an object is by conduction. The third method by which we can transfer charges from one object to the other is by conduction. In order to understand about conduction, we will do a simple experiment using an gold leaf electroscope. So this is the apparatus of a gold leaf electroscope. Okay. It is a glass jar which is fitted with the mouth of the glass jar is fitted with a one-hole cork. Okay. You have a brass rod here and this is a gold leaf or gold metallic plate. We can use even aluminum foils which we have in our house also. Okay. So this is kept open in shape V shape. This is V shape. Now I take a glass rod and I rub it with a piece of silk. And I take a glass rod and I rub it with a piece of silk. The glass rod will become positively charged. Okay. So, the glass rod has become positively charged. I bring the glass rod which is positively charged and I make it touch this rod which is kept on top. Okay. I am repeating once again. In order to understand conduction, I have taken an apparatus called as a gold leaf electroscope. It is a glass jar on which the mouth of the electroscope is fitted with a one-hole cock. Okay, a thin brass rod passes through it and the end of the brass rod is fitted with a piece of gold. We can use even aluminum foils which we have in our house. Now I take a glass rod and I rub it with a piece of silk. I find that the glass rod becomes positively charged. I bring this positively charged glass rod and I touch the electroscope. Now the positive charges from the glass rod will be passed on to the electroscope and it will also pass through the gold leaves. How do we know it has passed? As I mentioned earlier, like charges will repel each other. Since both the leaves of the electroscope are receiving the same type of charges, you find they will move away from each other or they will diverge away from each other. This shows that the glass rod is charged. So, this is a way of conduction. So, on same type of charge I am conducting from one object to the other, from the glass rod to the electroscope. Okay. So, this is the third way of conduction. Okay. Now, if I remove the glass rod from here, and if I touch the electroscope with my hand, you will find that the charges, the electroscope will come closer, the leaves will almost come closer and collapse. It is because all the charges will pass through my body and it will pass through the earth. This is called as earthing. Okay. So far we have seen three types by which we can charge an object. The first one is by friction, second one is by conduction, and the last one is by second one is by induction and the last one is by conduction. Okay. Now we are moving on to lightning. As I mentioned earlier, Benjamin Franklin's experiment. Okay. So when two clouds rub against each other or when the clouds and the winds rub against each other, a lot of charges get accumulated in the atmosphere. When it gets accumulated in the atmosphere, you find that when lot of charges get accumulated in the atmosphere, it induces opposite charge on the earth. Okay. So clouds are there, say the clouds are positively charged now. Okay. Upper part of the clouds are positively charged. The bottom part of the atmosphere will become negatively charged. Okay. Now these two are opposite charges. Now since this is a negatively charged, on the earth's surface, it will induce positive charge. The upper parts of the clouds become positively charged as they rub against each other and the negative charges are pushed to the lower part of the clouds. This negative charge will induce positive charges on the surface of the earth. So what happens when unlike poles meet each other? They will attract. When this, since I am drawing just 4 or 5 charges to show you, but in real millions and millions of charges are getting accumulated. So when these charges come in contact with each other only, you have a bright spark of light that is called as lightning. So when this lightning takes place, lot of heat is being generated. So the molecules also expand, resulting in the sound of thunder. Okay. So how do you save yourself from this lightning? How can we save ourselves from lightning? If you are indoors, better we don't use any of the electrical appliances, or better we don't take a bath or use the water which is at home. If you are outdoors, it is safe that we don't take shelter under a tall building or a tall tree. We should see to that we are the smallest target in that particular place. We should take shelter inside a small building or a small tree. Next, if you are in an open ground where you cannot take shelter under any tree or any building, what can we do? We can sit in a couched position where we become the smallest target for the lightning to attack us. Okay. Now, if we are living in tall buildings, you have so many tall buildings in our city. How can we protect these buildings? Though we are safe inside the building itself should be protected from lightning. For this, you have a device called as the lightning conductor. How does this lightning conductor work? Okay, a huge tall building is there. Say this is the tallest building in your area. How can we protect this building from the lightning? Okay, you can fit a device called as a lightning conductor at the topmost floor of your building. The lightning conductor is nothing but a piece of metal. The lightning conductor is nothing but a piece of metal. One end of this lightning conductor is seen up, and the other end should be tied to a metal rod or metal string. This metal string is tied to a metal plate. It is tied to a metal plate which is kept deep inside the earth. The lightning conductor should be placed in a topmost floor of the building. One end of the conductor is facing up and the other end is fitted with fitted to a metal rod or metal string. The metal string is tied to a metal plate which is kept deep inside the earth. So how does this lightning conductor act, or how does it save the building from lightning? Okay. When a lightning strikes the building, the lightning conductor will absorb all the charges, all these charges it will absorb. It will pass it through the metal rod and then it is passed on to the metal plate which is kept deep inside the earth. Okay. So all the charges will pass very much deep inside the earth and it will not affect any of us by any way. So this is only the working of a lightning conductor. This is one way of saving the building from the lightning. Okay. So this is next topic that we are going to see is about the earthquakes. How does an earthquake occur? Inside the earth, inside the surface of the earth, there are many many plates called as the tectonic plates. The plates which are there inside the earth, they are not stable or they are not rigid in their place. They keep moving. They keep moving against each other. When these plates move against each other, sometimes they rub each other or sometimes one plate moves another. So when these things takes place only you feel the earthquake. Certain earthquakes are recognizable and whereas certain earthquakes are not recognizable because it is of smaller magnitude. So once more I will repeat, there are so many plates like structures which are deep inside the earth. So when these plates move against each other, sometimes they rub each other or sometimes one plate moves against another plate. So this only leads to or causes the earthquake. When you find people affected by earthquake, what should you do? Immediately we should be able to or we should be willing to do some first aid for those people. Okay. So when you are inside a building, you see to that you get you get under a table and you save yourself. Okay. If you are outside, don't move, stay in a place stable. Okay. So how does these earthquakes occur? This is the earth. We are living on the surface of the earth. Okay. So deep inside the earth, as told earlier, when the two plates brush against each other or move against each other, earthquakes occur. So the point where the earthquake is starting, that point is called as the focus. Okay. And the point directly above this focus point, where we feel the earthquake on the surface of the earth, is called as the epicenter. Okay. So this epicenter zone only is highly affected zones by the earthquake. Okay. So if you are living in an epicenter zone, you will be highly affected. Of course, the effect of earthquake will be felt in the regions all around. Okay. Next, these zones where earthquakes are frequent, where in the world you find Japan is a seismic zone. They say Japan is a seismic zone or a fault zone because Japan is always an epicenter for the earthquakes. It is a place where earthquakes occur very frequently. So, places where earthquakes occur frequently are called as seismic zones or fault zones. And the place where the earthquake starts is called as the focus, and the radius directly above the focus where the earthquake is being felt is called as the epicenter. Okay. The next topic that we are going to see is about the volcanoes. All of you would have seen volcanoes. How does a volcano occur? Because of disturbances deep inside the earth and because of cracks, thin line crack, mountains are narrow. As you know that when compared to the other places of earth, other surface of the earth, mountains are narrow, so they are very weak zones when compared to the plateaus or the plain surfaces. So, through these cracks, the molten lava which is deep inside the earth is pushed out of the mountains called as volcanoes. The next one, you have the landslides and the avalanches. Landslides and avalanches, it takes place in mountains. Landslides, when there is a slide, when mountains get eroded from these, when soil get eroded from these mountains, you call it as landslides. When the same thing happens in snowy mountains, they are called as avalanches. When soil erosion takes place in landslides, they are also called, in snowy mountains, they are called as avalanches. The next one or the last one of the lesson is the tsunami. Tsunami is a very familiar term to all of us. It is a Japanese word. It means harbor wave. It means harbor wave. What is the cause of tsunami? Tsunami is nothing but it happens due to some explosion or earthquake under the sea. Okay? It causes a lot of destruction to life and property. So, we have to be careful. So, tsunami, I am repeating it once again, it is a Japanese word meaning harbor wave. It is caused because of the some explosions or earthquakes which occur under the sea. Thank you.